Let's take a look at Newton's second law of motion. And Newton's second law discusses the relationship between the force and the mass of an object and how it affects the acceleration of that object. So the formula F equals ma is often related to Newton's second law. Let's break that down a little bit. When we talk about acceleration, we're referring to the change in velocity or speed of an object. And there are two things that can affect the acceleration of an object. If we look at our formula, those two things are force, which is F, and mass, which is m. If an object has a larger force acting on it, then there's going to be a larger acceleration or greater acceleration. If there is a smaller force acting on an object, then it's going to have a smaller or a decreased acceleration. We would describe this relationship as directly proportional, meaning that when one goes up, the other goes up. When one goes down, the other goes down. It's directly proportional. The mass, however, has a different relationship. When you have a larger mass for an object, it tends to have a smaller or decreased acceleration. When you have an object with a smaller mass, then that object tends to have a larger acceleration. This type of relationship, when one goes up, the other goes down. When one goes down, the other goes up. This can be described as an inversely proportional relationship. It's an inverse relationship. They're opposites. Let's look at an example. So I've got a skateboard here, and I've got a car. And if we were going to describe the acceleration of these objects, this is a car, I promise. If we were going to describe the acceleration of these objects, we would want to look at both the force applied and the mass. Let me fix that car, make it a little bit more realistic. There we go, a little better. So first, let's look at the force applied. If I applied a large force to this object, a large force, say a big kick, then the acceleration of that object is also going to be large. Same thing here. If I applied a large force to my car, then it's going to have a large acceleration. And that makes sense. However, if we looked at mass, it's going to be a different story. If, let's say, I applied a force of 100 newtons, so a relatively large force, we look at the mass of the skateboard, it's a smaller mass compared to the car, its acceleration is going to be much larger. The force of acceleration is going to be very large. If I applied that same 100 newtons here to my car, since the mass is larger, its force of acceleration is not going to be as large when compared to the skateboard. And that makes sense based on the inverse relationship. If it's a smaller mass, a larger force is going to have a larger acceleration. If it's a larger mass, the same force is going to have a smaller acceleration. And that is Newton's second law.